Welcome everybody. Welcome to the webinar about what's new in TeamCity 2018.2. My name is Anton Arhipov and I'm a developer advocate at JetBrains, and I'm going to talk about the new exciting features in the new release of TeamCity that we have delivered just recently. The new release brings you quite a few interesting features. First of all, the secondary node, which is aimed at improving the scalability of the server. Support for GitHub pull requests, we are going to see a demo of that. That is quite exciting one. Now it's possible to install the plugins without restarting the server, which is pretty cool, I would say. If you work with Kotlin DSL for your build configurations, we have added a few helpers in the UI to actually help you with the task. A new cool feature has been added to the distribution called automatic assignment of the investigations. We are going to see the demo of that as well. And one more interesting feature, metadata in tests, so you can add artifacts, values, any kind of metadata to your results when the tests run. So let's see first how the secondary node works and explain you how to configure that. So the secondary node takes the load off the main server. So you will have two TeamCity servers running. The main TeamCity server will be responsible for, configuring the build configurations, managing the users, managing the build queue, talking to agents, and so on. And the secondary node will be polling for the external repositories. So basically that's an improvement over the read-only node that was introduced in 2018.1 last year. So now basically you should be thinking of this new node as a secondary node, which has more responsibilities than just displaying the data. It's now capable of polling the external repositories. So how does it work? So you will have two servers running. You need an external database for that. There is a version control repository and there is a developer making his changes. And the secondary node will be polling for the external version control system. And once the user actually commits a change to the version control, he makes a change to the source code, the change goes to version control. The secondary node discovers the change, it will pull in the change, it will store it to the database, and then the main server will pick it up and actually run the build. Another scenario is when you have installed the commit hooks to the version control. In this case, you don't really have to do anything. The developer will make a change, push in the change into the version control. The commit hook will trigger over the main server. The main server will actually create a task for the polling node. The polling node will go to the version control and pull in the changes and store them to the database and proceed as usual. So for installing the secondary node, obviously you will install that to a different host, but in my case here, to demonstrate how it works, I have installed two TeamCity servers into different directories and have modified the configuration accordingly so that it wouldn't occupy the same port on the same machine. To start the secondary node, I actually have to set up an environment variable called TeamCity server ops, where we actually assign a Java system property, TeamCity server node ID, and give it a value. In my case, I have called it secondary, and then we just start the TeamCity server by using the standard script. So I have the main server running in this tab. As you can see, it's 8111, the default port of TeamCity. And when I started the second one, I have assigned a different port, a different HTTP port for the secondary node, and it's now running on 8222. and the UI displays the banner that we are running. We are actually displaying the secondary node here, and I can navigate to the main node. So in the administration view, in the nodes configuration, I will see a list of the secondary nodes that I have configured, and by default they just run, and the responsibility is not enabled. So as you can see, there is like a responsible for column in this table, and VCS repositories polling is the responsibility for the secondary node, and the checkbox will be disabled when you start it for the first time. So you have to enable that, and automatically the responsibilities will be transferred to the secondary node. And it also displays some stats, how many times this new responsibility for the secondary node has been triggered. In my case, it hasn't been triggered for the last hour, so I have a 0 in this column. So when it starts working, it actually will start incrementing this counter here. So that's it. That's pretty simple to set up, and you will have 2 nodes running. Obviously, in your production environment, you will be running the TeamCity servers on the different hosts, not in the same machine. And remember to set up the external database for that. All right. So the second feature that we have in the new release is the GitHub pull requests. Let me demonstrate how it works. So first of all, I have a project here, which has one build configuration, and in the build configuration, I have configured 2 build features. The first one is the one that we are going to look at, is the GitHub pull requests. So there we have configured that the pull requests should be handled for that VCS route. In my case, it will be a repository at GitHub under organization account. And then I have configured the access token, and then we are going to say that only the pull requests that are coming from the members of the same organization are going to be built automatically. Okay, and the second feature I have configured just for tracing is the GitHub commit status publisher. So when the build runs and it succeeds, when it's finished, the status will be published to GitHub pull request, and we are going to see that, hey, it has been handled by TeamCity. Okay, so for this repository that is monitored by this build configuration, I have a second user in the different browser. I have logged in with this different user. I am going to make a change and create a pull request, and we'll see how TeamCity handles that. So let's go to this application file and say that we don't need some sort of code here, just remove it and remove some code and propose the file change as a pull request. So GitHub is going to create a new pull request now, and we are going to see how it triggers. The change has been detected, the build has started, we see it's running now, and once it's complete, let's preview the status of our pull request here. So there is a pending check, the TeamCity build has started, and once the build complete, it actually will display the status. Okay, the successful check. One successful check. The build has finished. We can navigate to the details for the build. And since TeamCity knows that it was building it as a pull request, it actually will display some additional information that it has built a pull request that was submitted to the master from that branch, actually from a fork, and by that user. Okay. Another new feature that we have added in the latest release was simplifying the installation of the plugins. So if we go to the plugins list and browse the plugins repository by pushing this button here, push the button, and TeamCity will ask if we want to send some information to the plugins repository for it to be able to suggest the automatic installation. We click the proceed button here, and we are now in the plugins repository. Now, for instance, we would like to build Rust applications, and Rust plugin is there. We locate it in the repository, and in the list of versions, we have this little get button here. So if we click on that, the drop down will display not only the download button but also the install, and localhost 8111 is basically my host here. So I'm going to click that button, and TeamCity will automatically suggest installing this plugin here. So once I install it, it will proceed with the download completed, and it will suggest me to enable the plugin without restart. So I click the button here, enable, and I have the new plugin enabled. So what will happen next actually is that the new tooling that came with the plugin requires update on the agent side as well. So the agent will be automatically updated when you install the new plugin, and the agent will disconnect, update the tooling, and restart. It takes a few minutes, depending how much it has to download, how much new tools it has to download. Now we can see that the agent has disconnected. We have 0 agents connected right now to the server. The agent is now restarting. Once it's up and running, we'll have the counter updated. It is now. And we are now actually able to build Rust projects. Let's see and test how it works. So I know that there is one nice project called Iron, which is a web framework for Rust. So let's try building that one. We are going to create a new project. Create project from the URL. Proceed. So what TeamCity should be able to do now is to suggest the build steps accordingly, as there is cargo used for building this Rust project. So it suggested cargo steps in here, and we can just select to enable those steps, use selected, and we have two of those steps enabled, and now the configuration is actually able to run without restarting the server. So that was the main point. Another nice feature that we added recently was a little helper button that helps you configuring your projects using Kotlin DSL. Let's see, we have a project called Pipeline in here, and it has quite a few build configurations. And this project is actually configured using Kotlin DSL script, which I have open in IntelliJ here. And you can see this is the configuration script. So here is the library build configuration, which we have in the UI right here. So let's see and preview the settings. So if we open the build configuration for editing, on the left, on the very bottom here, we can see the view DSL toggle, and if we click that, it actually previews, it opens the Kotlin DSL definition for that specific build configuration, which I have here. It previews the build configurations one by one, so there is no one-to-one matching that I have in the file. As you can see, I have many build configurations. So in the UI, it only displays the configuration for the specific build configuration that you are currently editing. Here, as you can see, I have a features block, and suppose I want to configure a new build feature, but I don't really know how to configure that in Kotlin. And what I can do now is to go to this build features page, open the dialog, and select the build feature that I want to add. For instance, it will be the investigations auto assigner, which was added in the last release. I can actually configure it with the values I want. So for instance, the default assignee will be the admin. And now I can preview this build feature in Kotlin by clicking the toggle. It actually displays me the code snippet that I can just copy and paste into the script, and then commit and push into the repository. Commit and push, and TeamCity will detect the change. There is a new version of the settings. It will pull in the change and reconfigure the pipeline. So let's see. In the version settings, I should be able to see the new status, and the change was applied. And let's see the new version of the library build configuration. It has the new build feature configured, the investigations auto assigner. So we have used the preview button to configure that, and it helped us with authoring the configuration. What is cool though is that when you open any of those screens, any views of this build configuration, let's say the build step, and if we push this toggle again, the specific place will be highlighted. So in this case, we are located in the build steps menu item, so the steps part of this build configuration is highlighted. And if we go to the build features again, then the build features part will be highlighted in the UI. Okay, so now we have this investigations auto assigner configured, and let's see how it works. This build configuration, this library build configuration, has one VCS root configured, which is running on my local machine. And let's see. So the investigation should be assigned automatically to the owner of the commit or to the default user if something goes wrong. For instance, we will modify the test so that it will definitely fail. Assert equals 1 to 2. Commit the change. The change should be detected by TeamCity by now already, and should be running the builds. Okay, let's see the pending. The change is pending, and once the build runs, it will fail obviously because of the test failure, and the new build feature will automatically assign an investigation to the admin user. Let's see what's the investigation, how it looks like. So the test is failing. Assigned a few seconds ago. It was automatically assigned to myself, and I was the only committer on that build. So it actually detected that the commit was made by myself, and it has assigned the investigation automatically to me because I was the committer. and obviously it displays a few more lines to tell me what's wrong with that. Okay, so this way it's working, and it's really nice, and our teams are using it internally already and pretty happy with that. So the last feature that I wanted to talk about was the metadata in tests. And in GitHub we have a sample repository that demonstrates how to use that and how to attach metadata to your tests. So you can actually try it yourself. It's very easy. There is a build configuration in Kotlin DSL included into that repository. As you can see, there's a .teamcity directory with the settings KTS. So we can actually just take the URL here and create a new project from the URL. Create new project. Proceed. So it suggests that you can import the settings from settings.kts. So let's do that. And it has automatically created the build configuration from those settings. It doesn't have a trigger because we don't want to trigger the builds automatically for this build configuration. And let's see how it runs. So there's TeamCity test metadata demo project. It doesn't have any builds run yet, so let's click the run button and see the results. So while running, it will execute a few tests, and those tests will include attributes with the metadata that we are going to render in the results. To actually see how to attach the different attributes of the data, you can see this codetest.kt file, which demonstrates how to do that. And basically, what it is doing is printing the service messages, TeamCity service messages, to attach the metadata for the test, for the specific test execution. So ## TeamCity is the format of the service messages in TeamCity, and now there is a new command called test metadata with a few attributes that you have to specify, and then you will be able to attach those attributes to the test results. And there are different types of messages. So for instance, in here we have a number type, but there below we also have a type of image, and we also have a type of artifact. So there's just currently 4 different types. The one by default is the string, so it's just a k-value pair. Then we have a number, and the number value could be historical one. So basically we are going to display a history of that value over the period of time. So basically how many builds you run, you will see the historical information for this attribute. And if you want to attach a file, in this case it's just the HTML file, and you can render an image. Basically, if you have a screenshot created during test execution, you will be able to render that in TeamCity UI directly. So let's see, the build has run, there are a few tests failing. Let's see how TeamCity displays the information. 2 tests are failing. So let's see all the tests. List of results. We can see a little icon that basically is the metadata pop-up. So you can render it in the pop-up, or if you go to the results of the test, it also displays it on the overview page. As you can see, we have a file attached, we have a screenshot that is just rendered as a picture, and we have the k-value pairs, the string values, and if we have a numeric value, we have a 2D graph. If you have many runs for this build, you will see a nice line here as well. So I hope you enjoyed the webinar. We have seen a few new features that are quite interesting ones in the new release. So the secondary node, easy to set up, takes off the load from the main server. If you have a big installation and many VCS routes, it's going to help you. Then we have a pull requests for GitHub now, incorporated into the main distribution. Installing plugins is now without restarting the server. Easier to author Kotlin DSL configurations, automatic assignments of investigations is a pretty cool one, and you can attach some metadata to your test results as well. So thank you for listening, and if you have any questions or feedback, please feel free to write to our forums or send us an email. Happy building!